The diagram shows a 120-degree sector cut from an annulus. The circles share one center, the outer radius is 13, and the inner radius is 5. We need the exact area of the shaded ring-shaped sector.
The choices are 144 pi, 73 pi, 48 pi, and 169 pi. Because every choice contains pi, our job is to determine the correct coefficient and keep the answer exact.
Let us inspect the source diagram. The shaded region lies between two concentric arcs, and the same pair of rays bounds both arcs. The marked central angle is 120 degrees.
An annulus is the region inside the larger circle, but outside the smaller circle. Since the centers coincide, we can find the full ring by subtracting the inner disk from the outer disk.
My first impulse is to use pi times 13 squared and call that the area. That would give 169 pi, which is one of the choices.
That calculation includes the circular hole and also includes all 360 degrees. The shaded region is neither the whole outer disk nor the whole annulus.
So I should first compare the areas of the two complete circles. The outer radius is 13 and the inner radius is 5.
Exactly. The full annulus has area pi times the difference of the squared radii. Keep the subtraction inside the parentheses so the inner disk is removed.
Substituting the radii gives pi times 13 squared minus 5 squared. 13 squared is 169, and 5 squared is 25.
Subtracting gives 144. Therefore, the area of the entire ring, before taking any sector, is 144 pi square units.
That explains choice A. It is the area of the complete annulus, but our shaded sector covers only 120 degrees.
A sector's area is the same fraction of the circle's area, as its central angle is of 360 degrees. Here the fraction is 120 over 360.
The diagram confirms that fraction. 3 sectors of 120 degrees would make a full turn, so the shaded region is exactly 1/3 of the full annulus.
Now combine the two ideas in one expression. Take 120 over 360 of pi times the difference between 13 squared and 5 squared.
We already know the squared radius difference is 144, and the angle fraction is 1/3. So the calculation becomes 1/3 times 144 pi.
1/3 of 144 is 48. The exact shaded area is 48 pi square units.
Let me verify the result another way. The outer 120-degree sector has area 1/3 of 169 pi, and the inner sector has area 1/3 of 25 pi.
Because those fractions have the same denominator, subtract the numerators. 169 minus 25 is 144, and 144 pi over 3 is 48 pi.
The source figure also supports the scale of our answer. 48 pi is smaller than the full annulus area of 144 pi, and it is exactly 1/3 as large.
Choice D, 169 pi, ignores both the whole and the angle. Choice A removes the whole but forgets the angle fraction. Choice B does not match either correct area relationship.
Therefore, choice C is correct, 48 pi. We subtracted the inner circle first and then kept the 1/3 determined by the central angle.
For any annular sector, use this reliable sequence. Subtract the squared radii, multiply by pi, and scale by the central angle over 360 degrees.
The whole changes the area, and the angle changes the fraction. Account for both, keep pi exact, and the shaded area is 48 pi square units.